our 3 models done. Thank you very much. You did a very good job in explaining. I just have one question, just to clarify. For student number 2, you draw lines that are wavy for the smell of toast and lines that are wavy for the wind. Do you do that because you're saying that they move the same way? Is that why you use the wavy lines in both? Yeah? So we'd say that they're same movement. Okay. So now let me just take a look here. So I noticed in your 3 models that there's a similarity in 2. Can anybody identify the similarity in these models? I think one is that the student number 1 used wavy lines for air and a straight line for smell, but we identified that he said that they're both the same size in which they are released into the air. Student number 2, you just said that they have the same movement, the wind and the smell of toast. Wind is made up of air. So I think those are similar. So we would say the 3rd model is the one that is a little bit different from the other 2 models, because we see that the smell of toast is represented by these little dots, which kind of is similar to what student number 1 identified by saying that the smell and the air are the same size, but they're smaller than the waves in the straight line. So these little dots are actually smaller. So there's another similarity. So now I think these dots are very representative of actually what we're doing when we breathe in, is smelling from a distance particles. That's very good, student number 3. So what it seems here is that this is more smaller than the other lines that were used to represent air, wind, and smell. So student number 1 said earlier that it was smaller. I should have marked that down. Smaller. But it's okay because I remembered. And here the actual illustration shows that the smell of toast is smaller. So that's very good. What I'd like to do is ask if anybody has anything to add to explain to me what they drew. If not, I'll move on to the next part of the lesson.
Well, to me, it all clicked when you opened the jar and the smell started spraying away. It reminded me of when people used to release a big bunch of balloons into the air. So it starts all clumped together and they get further and further away from each other, and then they fill up the whole sky.
That's a good observation, and it definitely represents here in your illustration the same thing. So now I will use the 3 of your models and work on building a consensus model where we put all of our ideas into one model and make sure that it represents us all. So what can we agree on for sure is that we do smell the odor, and everybody used the toaster, so I'll use that again. Sorry, because I don't really have artistic skills, but that's my toaster. I'll say toaster. Okay? Now, what we have in our 3 models that we agreed were similar is that we know that when we have the question, how do we smell odors from a distance, we said that there's movement, that it escapes from the container. I heard earlier somebody say that it escapes from the container. We can tell that by student number 2 saying that the wind causes the odors to have to move, which it says same movement. So you said that wind and odor moves the same way. So we know that there's movement involved. So it has to travel. So we understand that everybody here agrees that in order order to smell something from a distance, the odor travels. So let's demonstrate that, and at the same time, we agree that there is odor in the air, that it moves the same way, and that the size is smaller than the waves in the straight line, as illustrated here in student number 3's model. So let's try to condense that into one model, where we say that the smell is smaller, like we said earlier, smaller than the wavy lines, and that it moves. So we see that it moves in the air and reaches our noses where we smell. So how do we think that the movement happens if there's no wind? If we're stuck in a room where there's no wind, do you believe, like earlier when I let you smell, I didn't create any wind? Do you believe I should have pointed it out that I didn't create any draft or wind when I was holding the sample number 1 and everybody said they didn't like that smell? How do you think that it escaped from the jar? Kind of backtracking a little bit without the wind.
It has to move on its own.
Yes, and do you think that there's something else that creates some kind of movement?
The heat from the toast.
Heat from the toaster, that's an excellent answer. Actually, when the toast is being heated, that's when we smell it, because before there's no heat, we don't smell it. So it's an excellent answer. Something that is similar to what I did earlier is that we're indoors. We're in this closed door house in this room, and there's heat. There's room temperature, so there is some kind of heat going on, and this is when these little smells and the air happen to move. So that's very good observation. And now that we're able to establish that, I will name this the odor. And these little dots, does anybody know what these little dots are called?
Particles.
Particles, very good. Particles. And student number 1 said that the odor, the smell, and the air are the same thing. So that was very good observation. I'll mark that down. So what have we learned from our models and our answers is that when we have heat, that's when an odor begins to rise into the air, and we smell the odor. The odor has particles just as air does, and that's how we get to answer our question of how do we smell odors from a distance. So what we had earlier is what we know is wind. There's dust in the air, there's odor that escapes and goes into the air, what we can't see, and the smell travels. So what we want to know more of is how that gets into the air to travel, and student number 2 was able to identify that there's heat involved. So that's very good. This is what we wanted to know, and that's a good answer, and it's true. And now we have our consensus model, which tells us that these little air particles, when we said they're the same, air and odor are the same, right?
Yep.
So we say they're the same. Does that mean that these little particles, if we're breathing air all the time, is all around us?
Mm-hmm.
Yeah? Would you agree?
Yeah.
Mm-hmm.
Yeah? So that's pretty interesting that we're able to figure out that these little air particles are all around us, and that when we breathe in and we get these little particles into our noses. And these particles actually come from the bread, which is toasting from the heat and gets into the air. So those particles are actually part of that bread also. Would you agree?
Yeah.
Yeah. So these particles seem to be everywhere and all around us. And knowing that these particles are all around us must really be important, and it is important. It's called matter, and matter is basically everything that we're made of and everything that is around us. So that's what we're able to discover today in our question, and matter is made up of everything and all around us, and that's what these particles are. So I'm really happy that everybody participated, and if you have any questions, I'd be happy to answer for you.
What if it's not hot?
If there's no heat?
Yeah.
Earlier we didn't have any heat in the house. I mean any direct hot heat, but we had room temperature heat, and the air still, the odor still traveled in the air. I know our time's up, but if it's really cold and there's no heat, like let's say we go to the North Pole or like the Arctic where it's really cold and we want to smell something, we'd have to get closer. It wouldn't be from a distance anymore. We'd have to try our best to put that odor right under our noses to smell, and it would no longer be from a distance. But it's a very good question. Thank you for asking, and my time is up, and I'm finished. Thank you.